Today we are going to learn about AI bias, identifying and mitigating risks. We'll explore how to identify biases in AI models and learn strategies to effectively mitigate them to ensure fairness and trust in AI systems. Welcome to our video on AI bias, identifying and mitigating risks. As artificial intelligence becomes more integrated into our daily lives and decision-making processes, understanding and addressing biases in AI models is more important than ever. In this video, we'll discuss what AI bias is, how it can impact fairness and trust in various sectors, and what you can do to identify and mitigate these biases effectively. By the end of this video, you'll be equipped with the necessary skills to detect biases and implement strategies to ensure AI systems operate fairly and equitably.
AI bias occurs when an AI system produces prejudiced results due to erroneous assumptions in its learning process. Biases can manifest in various forms, such as algorithmic bias, data bias, and user bias. It's crucial to distinguish between bias and error. While errors are unintentional mistakes, biases are systematic and unfair distortions in AI outcomes. Common sources of AI bias include bias training data, flawed model design, and unintended consequences of system deployment. For example, facial recognition systems have historically shown biases against certain demographics due to imbalanced training datasets. Understanding these aspects is the first step toward addressing AI bias. In this section, we'll delve deeper into these concepts, providing you with a comprehensive understanding of what constitutes bias in AI systems and how it differs from mere inaccuracies.
The training data used in AI models is a critical factor that can introduce bias. Bias in data often stems from historical biases, sampling errors, and annotation processes. For instance, if an AI model is trained on historical data reflecting past discriminatory practices, it can perpetuate those biases. Sampling errors, such as overrepresenting certain groups while underrepresenting others, can skew the model's understanding and performance. Additionally, annotation biases occur when human annotators inadvertently introduce their own prejudices into the datasets. These biases affect the AI's ability to make fair and accurate predictions. Understanding these sources is essential for developing strategies to prevent bias from entering the AI model right from the data collection phase. In this section, we'll explore each source in detail, providing insights into how they can be identified and addressed. Biased AI systems can have significant consequences across various sectors, from healthcare to finance, recruitment, and law enforcement. For example, an AI recruitment tool that favors certain demographics over others can lead to unequal employment opportunities. Biased AI in healthcare can result in misdiagnoses or unequal treatment recommendations across different patient groups. These biases not only raise legal and ethical concerns but also erode public trust in AI technologies. Moreover, the long-term societal effects of biased AI systems can perpetuate inequality and discrimination. In this section, we will examine real-world case studies, such as biased AI in recruitment, to understand the potential ramifications and the importance of addressing these biases promptly and effectively. Detecting bias in datasets is a crucial step in ensuring AI fairness. Techniques for bias detection include data analysis methods, statistical evaluations, and the use of specialized tools. Statistical methods such as distribution analysis and correlation checks can help identify imbalances in datasets. Tools like Fairness Indicators and AI Fairness 360 provide frameworks for assessing bias across various dimensions. Human oversight is also essential, as domain experts can offer insights that automated tools may miss. In this section, we'll explore these techniques and tools, providing practical steps and examples to help you effectively detect biases in your datasets. Understanding and applying these techniques will empower you to create more balanced and fair AI models.
Bias mitigation during model development is vital to ensure fair outcomes. Strategies include optimizing models to reduce sensitivity to biased features, involving diverse teams in the development process, and implementing feedback loops for continuous improvement. Diverse teams bring varied perspectives, reducing the risk of embedding unchecked biases. Feedback loops allow for ongoing evaluation and refinement of AI systems. Continuous evaluation through techniques like cross-validation ensures that the model performs equitably across different subgroups. This section will provide a detailed exploration of these approaches, offering actionable insights on how to incorporate bias mitigation strategies into your AI model development workflow.
Examining real-world case studies of successful bias mitigation provides valuable insights and lessons. For instance, a leading tech company successfully reduced bias in its facial recognition software by diversifying its training datasets and implementing robust bias detection tools. These efforts not only improved the software's accuracy across different demographics but also enhanced public trust. However, challenges such as resource allocation and resistance to change were encountered. By exploring these case studies, we can identify key takeaways and strategies that can be applied to other AI projects. In this section, we will delve into these examples, highlighting the impact and lessons learned from successful bias mitigation initiatives.
Several tools and frameworks are available to assist with bias detection in AI models. Popular options include Fairness Indicators, AI Fairness 360, and Themis ML, each offering unique features and capabilities. These tools can be integrated into existing AI workflows, providing automated assessments of bias across various dimensions. While some tools are open source, allowing for community-driven improvements, others are proprietary, offering advanced features and dedicated support. Choosing the right tool depends on your specific needs, resources, and the complexity of your AI systems. In this section, we'll provide an overview of these tools, discussing their advantages and considerations for effective bias detection.
Continuous monitoring is essential to ensure AI systems remain fair over time. Implementing monitoring systems involves setting up processes to regularly assess AI performance and detect potential biases. Periodic audits help identify emerging issues, allowing for timely interventions. Feedback from users and stakeholders can provide valuable insights for adapting AI systems to changing contexts. Ensuring long-term fairness requires a commitment to ongoing evaluation and refinement of AI models. In this section, we will explore best practices for setting up effective monitoring systems, emphasizing the importance of a proactive approach to maintaining AI fairness and trustworthiness.
As we conclude this video on AI bias, identifying and mitigating risks, let's recap the key points we've covered. We've explored what AI bias is, its sources, and its impact on real-world applications. We've discussed techniques for detecting bias and strategies for mitigating it during model development. We examined real-world case studies and introduced tools and frameworks for bias detection. Finally, we highlighted the importance of continuous monitoring to ensure AI systems remain fair and trustworthy. We encourage you to apply the skills and knowledge gained from this video and explore additional resources for further learning. Addressing AI bias is not just a technical challenge but a moral imperative for creating equitable and trusted AI systems.